Well, this is lesson 13.3, and it actually brings us back to something we did earlier in the year called direct variation. And hopefully you remember that if two quantities, x and y, are proportional, then we would also say they show direct variation. Okay? And that means that the graph goes through the origin. So we remember that if they are proportional, it goes through the origin. If they show direct variation, it goes through the origin. The one difference here is when we were talking about this earlier this year, it was represented by a direct variation equation, y equals kx, where k is the constant of proportionality. And I don't know why they use k for that. I wish they always used m, because we switched to m right now, and why we would start with k and switch to m, I don't know. If somebody figures that out, please let me know. So the graph of y equals mx is a line with a slope of m. So m is the slope of the line, and it passes through the origin, okay? Because it falls into this equation. We know it shows direct variation. We know it'll go through the origin. And that m value is the slope of the line. Okay, so let's look at their example 1 here. The cost, y, so our y value will be dollars, for x gigabytes of data, so gigabytes is our x value, on an internet plan is represented by y equals 10x. So we already know what the slope of this graph will be. The slope is 10 because that falls right in place of where m would be, y equals mx. Graph the equation and interpret the slope. So the equation is graphed over here. Gigabytes going by ones here. Cost in dollars going by tens up the y-axis. So here it shows 1 gigabyte, $10. And then this would be 2 gigabytes, $20, 3 gigabytes, $30, and it follows just like that. So then it says interpret the slope. And remember, when we interpret the slope, all we're going to do is put our units on there. So we don't just say the slope is 10. The slope is 10 what? The slope is $10 per gigabyte. Remember, it's always y over x. Dollars per gigabyte. So that's interpreting the slope there. So this should be just a big review of the direct variation lesson we did much earlier this year. And then it says, let's skip to the next one. Comparing proportional relationships. We did this earlier in the year as well. So here they show a graph of a 2-person chairlift at a ski resort. And then it says here, the distance, y in meters, that a 4-person chairlift, so different than this one, a 4-person chairlift, ski lift, travels in x seconds is represented by this equation. So they give us the 2-person lift in the graph and a different lift in an equation. And it says the graph shows the 2-person lift. Which ski lift is faster? So let's look at this one. The 4-person lift has a slope of 2.5, which is 2.5 meters per second. Meters per second. If we figure out the slope over here, it goes up 2 over 1, up 2 over 1, because these are going up by an interval of 2, so up 2 over 1. And that means 2 meters per second. So the 2-person lift is 2 meters per second. The 4-person lift is 2.5 meters per second, so the 4-person lift is going faster than the 2-person lift. And they show that graph right down here where they actually graphed both of them. And we might say, what does it mean that the 4-person lift, or the red line, is steeper than the blue line? And that would mean that the 4-person lift was going faster or has a larger slope. So it's more meters per second. It's going faster than the blue. Excellent. That really is the entire lesson here. It's a review of direct variation from earlier this year. So hopefully you can remember now that direct variation and proportional mean the same thing, and that both times they will go through the origin. And then the big difference for this one is instead of y equals kx, we're calling it y equals mx, okay, where m is the slope. So we put a value for y in, a value for x in, and then this is the slope right there. Excellent.